Alright, let's dive into the world of FDM 3D printing filaments in a way that's easy to understand, like we're in a classroom together. So, picture this. You have a 3D printer sitting in front of you, ready to create some awesome objects, but the big question is, what kind of filament should you use? The choice of filament is super important because it affects how your project turns out, whether it's strong, flexible, heat-resistant, or just looks really cool. We're going to talk about some of the most popular filaments, break down what makes each one special, and even discuss what kind of things you might print with them. 1. PLA, polylactic acid. Think of PLA as the beginner-friendly filament. It's like the training wheels of 3D printing, but don't let that fool you. It can be used for some really cool projects. What makes it special? PLA is easy to work with. It doesn't require a super hot printer or a fancy setup, so it's perfect if you're just starting. It's made from renewable resources like cornstarch, which means it's biodegradable and a bit better for the environment. Pros and cons. Strengths: easy to print, low risk of warping, and it doesn't smell bad when you print with it. Weaknesses: it's not very strong or heat resistant. Leave a PLA print in a hot car and it could warp or melt. What can you make? PLA is great for prototypes, models, toys, and decorative objects. Think of things like action figures, vases, or even simple household items that don't need to be super tough. 2. ABS, acrylonitrile butadiene styrene. Now, ABS is more like the tough guy of 3D printing filaments. If you need something strong and durable, this is a good choice. What makes it special? ABS is strong, impact-resistant, and can withstand higher temperatures compared to PLA. It's the same plastic used to make Lego bricks. Pretty durable, right? Pros and cons. Strengths: durable and can handle wear and tear. It's also easy to sand or paint, so you can make really polished-looking parts. Weaknesses: ABS likes to warp, especially if you don't have a heated bed. Plus, it gives off fumes, so you need good ventilation. What can you make? ABS is ideal for things like phone cases, car parts, or tool handles. If you're printing something that will get a lot of use or be exposed to heat, ABS is your friend. 3. PETG, polyethylene terephthalate glycol modified. PETG is kind of a middle ground between PLA and ABS. It's strong but still fairly easy to print with. What makes it special? PETG is durable, flexible, and resistant to chemicals. It also has good layer adhesion, which means your prints will be strong. It's a food-safe material with proper guidelines, so you could use it for certain kitchen items. Pros and cons. Strengths: it doesn't warp much and can take a beating. It's great for prints that need to hold up to physical stress. Weaknesses: PETG can be a bit stringy, meaning you might see little wisps of plastic between parts of your print. What can you make? Water bottles, protective covers, mechanical parts, or even phone stands. It's excellent for things that need to be strong and durable. 4. TPU, thermoplastic polyurethane. Imagine you need something that's not just strong, but also super flexible, like rubber. That's where TPU comes in. What makes it special? TPU is very stretchy and impact resistant. It's perfect for parts that need to bend, twist, or absorb shock. Pros and cons. Strengths: flexible and strong. You can make things that won't crack under pressure. Weaknesses: it can be tricky to print because it likes to jam up the extruder if you're not careful. You also have to print it slowly. What can you make? Think of things like phone cases, flexible joints, shoe soles, or wearable items like wristbands. Anything that needs to bend without breaking is a good candidate for TPU. 5. Nylon. Nylon is like the high-performance athlete of 3D printing filaments. It's tough, flexible, and can handle a lot of stress. What makes it special? Nylon is super strong and can withstand a lot of wear and tear. It's used for things like gears and parts that will be under a lot of load. Pros and cons. Strengths: high strength, great impact resistance, and it can handle high temperatures. Weaknesses: it absorbs moisture from the air, so you have to keep it dry. Otherwise, your prints will turn out badly. It's also prone to warping. What can you make? Gears, hinges, functional parts for machinery, or anything that needs to be durable and strong. Nylon is perfect for projects that need to last. 6. PC, polycarbonate. Polycarbonate is one of the strongest materials you can use with an FDM 3D printer. It's incredibly durable and can withstand high temperatures. What makes it special? PC is super strong and heat resistant. It's used in things like bulletproof glass and protective gear. Pros and cons. Strengths: excellent toughness and heat resistance. Great for high-strength applications. Weaknesses: it's hard to print with because it warps a lot, and it needs a high-temperature printer. You'll also need an enclosed printer for the best results. What can you make? High-strength functional parts, protective covers, or even light fixtures. If you need something that can take a beating, PC is a great choice. 7. Wood-filled filaments. These are PLA-based filaments mixed with wood fibers, giving your prints a wood-like look and feel. What makes it special? Wood filaments can be sanded and stained just like real wood. They give your prints a beautiful, natural finish. Pros and cons. Strengths: great for decorative prints and art projects. It's easy to make things look like wood furniture or sculptures. Weaknesses: more brittle than regular PLA, and it can wear down your printer's nozzle over time. What can you make? Picture frames, sculptures, or even custom furniture accents. It's perfect for artistic projects. 8. Carbon fiber reinforced filaments. These are composites that mix a base material like PLA, ABS, or nylon with tiny carbon fiber particles. What makes it special? The carbon fibers make the filament incredibly strong and stiff while still being lightweight. Pros and cons. Strengths: very strong and perfect for projects that need rigidity without added weight. Weaknesses: the filament is abrasive, so you'll need a hardened steel nozzle. It's also a bit more brittle and expensive. What can you make? Drone parts, frames for RC vehicles, or high-strength tools. If you're building something that needs to be both tough and lightweight, carbon fiber filament is the way to go. Number 9. HIPS, high-impact polystyrene. HIPS is often used as a support material for ABS prints because it dissolves in limonene, a citrus-based solvent. What makes it special? It's great for printing complex models with lots of overhangs because you can dissolve the supports away afterward. Pros and cons. Strengths: works well as a support material and is easy to post-process. Weaknesses: emits fumes, so you need ventilation, and it warps like ABS, requiring a heated bed. What can you make? Support structures for ABS prints, prototypes, or functional parts. It's also useful for models that need painting or finishing. 10. PVA, polyvinyl alcohol. PVA is another support material, but this one dissolves in water, making it very user-friendly. What makes it special? PVA is perfect for multi-material prints where you need clean support removal. Pros and cons. Strengths: completely dissolves in water, leaving your main print untouched. It's biodegradable and non-toxic. Weaknesses: sensitive to moisture, so you have to store it carefully. It's also quite expensive. What can you make? Intricate designs or models with complex internal structures. It's mainly used for support material in dual extrusion 3D printers. Wrap up: how to choose the right filament. So, when you're deciding which filament to use, think about what's most important for your project. Do you need something strong, flexible, or heat-resistant? Are you aiming for a beautiful finish or just a quick prototype? Each filament has its own personality, so understanding their strengths and weaknesses will make you a better 3D printing artist and engineer. Remember, the more you experiment, the more you'll learn about what works best for your projects. Happy printing, and don't be afraid to try new materials.